Okay, this is number 2 on page 219. We want to see whether those vectors can be written, each one on A, B, C, can be written as a linear combination of those two vectors in S. Okay, here is the set S. And let's do part A. Okay, here's part A, 1, -5, -5. So we want to see if this can be written as a linear combination of those two vectors. Well, we set that vector equals to C1 for times the first vector plus C2 times the second vector, and so for C's. Okay, here multiply C1 times each coordinate, C2 times each coordinate here, and I add, and what I get is this system, right? C1 plus 2C2 equals 1, negative 2C1 minus C2 equals to -5, that's the second coordinate. And then the third coordinate, negative 2C1 plus C2 equals to -5. Put that in the calculator, and this gives me this matrix. It's an augmented matrix, right? 3 equations and 2 variables, but I'm including the right-hand side so it becomes an augmented matrix, so I can solve this using the row-reduced echelon form for matrices using Gaussian elimination. So I put that in the calculator. Here it is. I already put the matrix here, I think. Yeah. Here it is. Let me move this over to the side. There's just 1, 2, 1, and 2, -1, -5, and so on. So let's reduce this. I have already reduced it for you. You can see, right? Here it is. It becomes 1, 0, 1, 0, 0. I have no idea why I put 1 here. It should be 1, 0, 0, 0, 1, 0, 0, 0, 1. So the conclusion is that, look at the last row. The last row, it's an impossibility, right? 0 equals to 1. So we can conclude there is no solution. Even though the first row says, well, C1 equals to 0 and C2 equals to 0, but that doesn't mean anything because the last row shows it's impossible. Okay? If the last row was a row of zeros, all zeros, 0, 0, 0, then yes, this would be a solution. Okay? C1 would be 0, C2 would be 0, and that's the only linear combination you can get. Okay? But not for this case. You can clearly see that this doesn't make sense, right? C1 equals to 0, C2 equals to 0 doesn't make sense, right? If I look here, let's say if I put 0 here and 0 here, clearly this is not 1, -5, -5, right? It's 0, 0, 0. Okay, that's because of the last row. The last row is saying that it's an impossibility. So there's no solution. U cannot be written as a linear combination of those two vectors here in S. That's part A. Okay, so here's the augmented matrix, and if I reduce that, so I already did here for you, you should get 1, 0, -2.8. I can easily convert that into fraction if I press math and fraction. So that is -14 over 5 and 2 over 5. Look at the last row, 0, 0, 0. 0, 0, 0. This is 0, 1, and then 1, 0. Okay. All right. So the conclusion is the last row is all 0, so we can just ignore that. That doesn't mean anything. We don't even have a third variable here. It's just C1, C2, so you can ignore that. But look at the second row. The second row says that C2 is 2/5, and the first row says that C1 is -14 over 5. So we can write the vector as a linear combination of those two. And then part C, let's check whether this can be written as a linear combination of those two. And right here, okay. And then find the C1, C2. Let's do that. And let's row reduce. Let's row reduce the matrix. Okay, here it is. Again, the last row doesn't mean anything. All zeros, we can just ignore it. and then C2 equals to 4, C1 equals to negative 9. And that's the linear combination. So the answer is yes, W, little w here, can be written as a linear combination of those two vectors, and these are the coefficients, these are the scalars. That's the end of it.